In the previous video, we looked at combining series. So now let's put it to good use. So let's try and sum up everything from the first term all the way to infinity. So we can break this up into two separate fractions. Break it up into two separate fractions. And when you have the difference of the two, you can actually concentrate on summing up everything here, and then concentrate on summing up everything here, and then just get this, take away this thing here. So in the previous video we looked at this, and it allows us to do this. So now let's try and tidy this up. So this is really a half. This is really a half here, and then this thing here, you can rewrite it as this, because if you have 1 over, let's say 6 to the power of 3, well, that's the same as 1 over 6 to the power of 3, because here 1 times 1 times 1 is still stays as 1. Because there's a 1 here, you can just basically push this out. So out here, so you can rewrite this as this. So now it's just a matter of us summing up this whole thing. Sum up this whole thing, and then we can get this, take away this. Remember, we've seen this in the past. This is a geometric series. So now you can see that this here is a common ratio here. This is our R here. N minus 1, n minus 1. It starts at 1. It starts at 1, and A happens to be 1. So our constant here is, so this A here is 1. And then if you look at this, our common ratio is 1 over 6, and this matches up with this. This matches up with this, and and A here is a constant. A in our case happens to be 1, so we can just simply apply this formula. So working this out will then give you this. This will then give you this whole thing here. And then you got your takeaway. Overall, it will come to 4 over 5. So here's another example. So making use of what we found in the previous video, remember K, the K is a constant, so you can just take it out. So this is what we've seen in the previous video. 4 here is a constant, so we can take it out. So we can just concentrate on summing up this whole thing here. Well, we can rewrite this as hang on, let me think. Sorry. Sorry, hang on. In order for us to make use of this formula, we require this to be n minus 1 and this to be n equals 1. Here you've got n equals 0, and then it starts at n. So here's the trick. Well, if you want to start at 1, then push it up by 1, but then take away 1 here. It's a trick, and it works because, well, let's rewrite this as this. So this at the moment is n equals 0. We're going to push it up by 1, but then minus this by 1. So that's this here. So we can let's rewrite this as this. So now let's test it. When n equals 0, this will be 1 over 1. When n equals 0, you put it into here, so it will be 2 to the power of 0. Now let's look at this bit here. When n equals 1, so you start at 1. When n equals 1, put it into here, it's still 1 take away 1, which is 2 to the power of 0, which is the same as up here. When you put 0 into here, it's 2 to the power of 0. Okay, let's look at the next term. Instead of 0, let's push it up by 1. So now put this into here. This bit here will be 2 to the power of 1. Now let's look at down here. The next term here will be 2. So the next term will be 2. Put that into here. So it will be 2 take away 1, which will be 1. So it's still the same as up here. Okay, let's push it up by another one. So now it's n equals 2. Put into here. So it will be, this bit here will be 2 to the power of 2. Now push this up. So now it's 3. Put it into here. So it's 3 take away 1, which is 2. So it's the same thing here. So the trick here is in order for us to make use of this formula, we we need n to start at 1. We need this to be n minus 1. So let's push this up to 1, and then take away 1 here. So rewrite this as this. Now everything's of the same form. N equals 1, n equals 1, and well, we can rewrite this. We can rewrite this as this. Okay, so now this here is a common ratio here. This is a common ratio. We've got n minus 1, and it starts at, hang on, my mistake, and it starts at n equals 1 to infinity here. So it starts at, sorry, hang on, let's start again. So our common ratio is a half, n minus 1, and then you've got n equals 1, infinity, infinity. So looking at this bit here, we could just blindly follow this formula here. So blindly follow the formula. This bit here will become this. 4 here is 4 here. Work it out. It should come to 8. Okay.